Alright, welcome to the last video in this chapter on systems of equations and inequalities. So in the last video we just learned about single variable inequalities and how to solve those inequalities. You just work backwards, solving for the variable the normal way, with the one exception that if you multiply or divide by a negative you flip the sign. And so when you're doing a two-variable inequality, the strategy is going to be exactly the same, except instead of having an answer of x is, say, less than or greater than a numerical value, here you're going to have your answer will have other variables in it. So if you're solving a linear equation, for example, you might want to get into the form y equals mx plus b so that you can graph it. But instead of y equals now, we would have y is less than or greater than or less than or equal to or greater than or equal to. So you're going to be rearranging the equation, solving for a particular variable. Typically, you'll be solving for y as a function of x because we're going to be dealing with linear equations and graphing them. So just like with the one variable equations, you had to differentiate whether it was the endpoint was included or the endpoint was excluded. So there you did it with a solid circle or an open circle, but here we have an entire line because the equation relating y and x, y equals mx plus b, that is representing the graph of an entire line. And so to include all the values, just like doing solid dots, you'll do a solid line. And to exclude the values, or to show that they're not included, instead of using an open circle like we did for a single point, you're going to use a dotted line. So you still have to show that it's the boundary between the two sides. One's the solution, one's not the solution. But if it's a dotted line, you're showing that that itself is not part of it. So an example might be something like a fence between your house and your neighbor's house. If you were to draw a map of your property, do you own that fence or does your neighbor own that fence? So whether you draw a solid line or a dotted line depends whether that fence is part of your property or not part of your property. So solid and dotted represents including a solution or excluding a solution. And then just like you had to shade to the left or to the right on the number line for x being greater than or less than, with these equations you're going to either shade above the line or below the line depending on the y value. So if you were to look at a graph, you'd have the y-axis vertical and the x-axis horizontal. And you're looking at the inequality written as y is less than or equal to, or y is greater than or equal to. And so the y values go vertically up and down. So suppose that you drew in your solution and it was this line like this. The only difference between the linear solution, which is just the line, and the inequality solution, suppose you have y is less than or equal to. You got a solid line. The y is less than means any value smaller than that is also a solution. So you would not only draw in your line, but you would also shade everything that is below the line, because all these have y values which are smaller than the y values that are on the line. So you're really just shading above or below when you've solved for y in this way. And that's all there is to it. Let's do a quick example. Let's try solving 2x minus 4y is, let's do greater than or equal to 8. So you solve the equation for y just like you would normally, converting for mx plus b, except it's an inequality instead of an equation. So the first thing we'll do is subtract 2x. Subtract 2x. So we have negative 4y is greater than or equal to. Remember, you can't combine these two, so we write it as negative 2x plus 8. And then to get y by itself, we should divide by negative 4. Divide by negative 4. Remember here, two things. Number one is we divided by a negative, so we have to flip this inequality. Instead of being greater than, it's now less than or equal to. And the second thing is everything on the right-hand side is being divided by negative 4. So you got to remember to do both of the things in the numerator. So negative 2x over negative 4, this part right here. Negative 2 divided by negative 4 is 1/2. So we have a 1/2 x, and then we have a plus. No, it's going to be minus because it's 8 divided by negative 4. So minus 2. Okay, so that's our solution algebraically. And then to graph this solution, we make ourselves a graph. We're going to graph the line just like normal because we have y is less than or equal to. So it's going to be a solid line because the line is included. The negative 2 here is our intercept. So we go down 2, we put our intercept. The slope is 1/2, so that means up 1 over 2. Let's put some ticks on here. So there's 2 and 4. There's negative 2. So we started here, we went up 1 over 2. Up 1 over 2. We can draw in a solid line through these points. So if the answer would have been y equals 1/2 x minus 2, we'd be done with that line. But it's y is less than or equal to. So we've got the line from the equals, and we've got to shade everything below it to count for the less than. So a way to check these kind of problems is to plug in the point 0, 0. That's very easy to plug in, right? So if you plug in 0, 0, according to our graph, it's not a solution because it's not part of the shaded region. So if we plug in 0, 0, we have 0 is less than or equal to 0 minus 2, right? Is 0 less than negative 2? No, it's not. So because this equation came out false, the 0, 0 spot is not part of our solution, and as we see, it's not shaded. So that means we've done it correctly. We have not shaded something that is not part of the solution. So if we would have accidentally shaded the wrong side, say we would have shaded up here, we would have seen that right away because we would have had this shaded, which means it's part of the answer. But if we plug in 0, 0 to the equation, it doesn't work, so we know it's not part of the answer. Okay. Now, just like with the single variable inequalities, we had two conditionals, the AND case and the OR case. We can do the same thing here with multivariable inequalities. We can do an AND. That's where you only include in your final answer the places where the shading overlaps. Both things must be true for the overall result to be true. And the other possibility is it's an OR situation. And here, anything that's shaded by any of your inequalities is going to be included. So for an AND graph, you might have a line here, and you've shaded above, and then you might have a line here, and you've shaded, say, below. So your final solution, if it was going to be an AND graph, so if it's an AND, your final answer is only going to be over here, because that's the area that was shaded by both of them. Okay. On the other hand, if you were to have something like an OR, if you were going to have an OR, if you had one graph and say this one was shading below, and then you had a second graph and this one was shading above, like this, and if this is an OR, it's going to be a lot different because anything that's shaded by either one of them meets the OR condition. So if this was to be an OR, all of this would be a solution, and all of this would be a solution. So if it's an OR, everything is a solution except this little region over here. So the solution for an OR is typically a lot larger than the solution for an AND. Okay, and that's all there is to it. You're going to practice solving linear equations by working backwards. Make sure you flip that inequality when you multiply or divide by a negative. And then practice graphing. Remember, whether it's a solid line or a dotted line. It's okay if you make it solid and you go back and you have to erase a little bit when you realize that it should have been dotted. That's totally okay. And then graph above or shade above or below the line. And make sure that anytime you have an inequality, you've got something shaded. So a lot of times students will forget to shade. They'll draw the line in, but they'll forget to shade above or below. So anything with an inequality, there's going to be lots of solutions, either all the ones bigger or all the ones smaller. So you should have a big shaded region on your graph. All right, good luck, and ask questions in class if you have any.